Hello everyone, Terry here with Micronics Training, and today what I want to do is I want to focus our attention to a continued discussion about VXLANs. So Virtual Extensible Local Area Networks is going to be the topic of this series of videos. And specifically we're going to follow through the progression of how VXLAN operates. We're going to begin with the introduction to VXLANs, and the easiest way to be able to do that is going to be focus on the idea of flood and learn behavior. And we'll get into the details of that shortly. But what I want to do immediately is I want to move into a conversation about how we're going to test this, how we're going to configure and implement our systems, and why we even need the VXLAN configuration to start with. So what I'd like you guys to do is I'd like you to lend me your imagination, and we are going to consider the fact that we have a host, and this host may be situated here in my studio in Virginia where I'm at. And that host is going to have an IP address. Let's just assume that IP address is 192.168.100.201/24. Now, I may have another host. Let's say over here I have another host, and let's just say this is host 2. And what we're going to do is we're assume that he's going to have an IP address in the exact same network segment as us. So we'll come over here and say 192.168.100.202/24. And what we want to do is we want to add another category to our conversation, and that's going to be the fact that these two hosts are going to be geographically isolated. Let's say, for instance, that this host is located in Virginia where I am, and let's say that this host is located in Maryland. Now what I want to be able to do is I want to be able to create a mechanism that's going to allow me to take this host that's going to be connected to a network resource located in Virginia, and this host, which is going to be, as I said, connected to a network resource that's located in Maryland. And what I want to do is I want to interconnect these resources via the creation of some type of layer 3 transport. Now what this is going to do is it's going to allow me to be able to take traffic from host 1 and encapsulate that traffic in such a way that the traffic is going to be able to travel across my IP transport infrastructure that we're going to be building. And the way that I'm going to do this is I'm actually going to accomplish this through the process of VXLAN encapsulation. Now understand that we need to have some resources that we're going to use to carry our traffic. And we're going to find ourselves discussing the idea of CLOS architecture. Now CLOS architecture is a leaf spine architecture that's going to allow me to be able to create an environment where no leaf is going to be more than 2 hops away from any other leaf. So as an example, H1 could travel to this leaf, to this spine, to this leaf, or it could travel from or to this leaf, to this spine, to this leaf. And what we see here is no resources more than 2 hops away. 1, 2, 1, 2. And as we go in and we start doing the implementation here, what we're going to want to do is we're going to want to make this a physical manifestation so that we can actually implement it, deploy it, troubleshoot it, and more importantly, for the particular aspect that I'm looking for, is I want us to be able to focus on what's happening on the inside of this, because what we're actually going to be doing is we're going to be building an IP transport underlay infrastructure that's going to allow us to be able to interconnect these hosts via a layer 2 adjacency mechanism. What we're actually going to be building is going to be a VXLAN fabric that's going to be supporting layer 2 VNI. So what the object here is we're going to obtain layer 2 adjacency between these resources through the communications and interconnection of this IP transport infrastructure that we're going to be building. And as I said in the very beginning, we're going to focus on the idea of flood and learn. And when we have flood and learn, understand that this is going to require us to be able to support multicast. Now we're going to spend some time talking about the way we're going to deploy multicast. The first mechanism that I'm going to be using is going to be something called Anycast RP. That's going to be our first focus, and that's going to allow us to utilize something known as Any Source Multicast Configuration, ASM. And you may remember that from our conversations about our layer 3 protocols. Right now we're focusing on overlays, and those overlays, whether we're talking about OTV or whether we're talking about the idea of VXLAN, those are going to run on top of this IP transport. And this IP transport, depending on our deployment mechanism, may need to support multicast or not, but at the end of the day it still has to be a layer 3 transport. Now, when I implement the layer 3 transport concept, what we're going to do is we're going to deploy OSPF, and we're going to do it in single area. Everything will be in area 0 for our deployments. And we're going to need to take these resources, and what we're going to want to do is we're going to configure this resource as leaf 101, this resource will be leaf 102, this resource will be spine 201, and this resource will be spine 202. And what we're going to want to do is we're going to want to focus on this transport layer first from the perspective of layer 3 unicast, and then second from the perspective of our configurations for multicast. So I'll see you guys in the next video, and the goal here is going to be to build this step by step until ultimately we've achieved a functional VXLAN environment using flood and learn with a Anycast RP deployment. And then what I want to do is I want to pull back the covers and take a look at the control plane mechanisms that are actually operating inside of this configuration deployment. I'll see you guys in that video.